Okay, Ayla is going to be talking about Peapods, a modular, reproducible, and versionable notebook of notebooks. Very meta.
Okay, thanks so much. Yes, so I'm Ayla. I'm a PhD student at UC San Diego. And yeah, I'll be talking about this design for a modular computational notebook. So as has been discussed a little bit already, Jupyter notebooks are an interactive programming environment that are very popular for data analysis. But Jupyter notebooks are messy, and this is something that a lot of people have talked about an awful lot. So we sort of try to characterize what this mess is along 3 dimensions. So the first is static mess, which is a form of conceptual disorganization. Dynamic mess, where code and its execution are out of alignment with each other. And then historical mess, where you have multiple versions of code with unclear relationships. So to see this a little more clearly, let's go through an example in Jupyter. So let's say I have some data set of IKEA products and I want to do some various analysis of it. Maybe at one point as I'm exploring it, I decide I want to drop some columns. But then in a later analysis, I need one of those columns, the height column that I dropped. And let's imagine that I really do want to keep that column dropped in that previous analysis. Then what can I do to reconcile these 2 things? Well, the first option is I could avoid mutating the original data frame and instead have multiple data frames. And while this is okay if I'm just managing a few variables, as the number of variables grows, this can be really challenging to manage. So we can think of this as a form of static mess. Another common cause of static mess in notebooks stems from the fact that cells are sort of overloaded in their functionality. So cells represent units of inspection, execution, and organization. So while it may make the most sense to keep related code all in one cell, if you want to inspect intermediate outputs, you may instead choose to break it across cells, which can be more confusing. Okay, so back to our previous example. Another option for reconciling this issue is to run my cells selectively. So maybe I run my code that loads in my data and then skip the stuff that mutates the data frame and then just run the later analysis. But now my notebook doesn't run in order, which is confusing, and especially if down the road I want to rerun this notebook and reproduce the same results, it's not clear how I do that because I need to do some run order that I don't recall, and that isn't reflected in the code. So this is an example of dynamic mess. So what are the underlying causes of messes? To some extent, mess is inherent to the work that happens in Jupyter, because a lot of Jupyter work is exploratory. So it's iterative and unplanned. It requires comparing many alternate paths. And so we don't really want to get rid of this mess or this opportunity to create these messes. At the same time, some of this mess is exacerbated by specific features of Jupyter's design. So the motivating question for this work is how can you support exploration while reducing these messes that are caused by incidental features of computational notebooks. So our approach is in the form of a modular notebook, which adds structures that group cells, introduces local scopes, and adds explicit dependencies and data with flow restrictions. Okay, so this is what Peapods looks like, and in a Peapods notebook, you have pods, which are essentially sub-notebooks, and within a pod, code cells can be run in any order, just like in Jupyter, but between pods, we have isolated heaps and import-export restrictions that are intended to localize our messes. Okay, so going back to the previous example that we saw in Jupyter, this is how it would work in Peapods. So first, in our first pod, we load in our data and export this data frame. Then in our next pod, we do this the same analysis as before, and we drop those columns, but because Peapods have isolated heaps, this only takes effect locally. And so in our next pod, we can import our original data frame from our first pod, and it's unaffected. So we avoid this previous error. Okay, so I used this term earlier that we're localizing messes. And to make this more specific, these are the 3 guarantees that Peapods provides. So the first one is that side effects are local, which is what we just saw. The second is that exported variables should be reproducible. And by this, I mean that in order to export from a pod, you must run it in full and linearly. And then finally, imported values must be consistent with each other. So for example, if pod 1 exports X and pod 2 sets Y to X, then if pod 3 uses X and Y are guaranteed to be equal to each other. Okay, so in addition to mess containment, because we have pods, now we have modules, and we can make use of these modules. So one thing that we can do is we can reuse them. Currently, the way that you reuse a pod is you can convert it to a function, turning imports into parameters, the cells become the function body, and then exports out the return values. And in future, we would like to make pods directly invocable without needing to make this transformation. Additionally, because pods are composable units, we can swap them in and out for each other. And so this lends itself, I think, nicely to this need to explore alternate paths and compare different approaches. And so right now we have sort of a minimal support for this in the form of pod variants, which you can see you have like those tabs for, and you can toggle between them to switch out your versions. But I think that we can extend this a lot to support more different kinds of workflows. Okay, so we're currently running a user study. It's very much at the beginning, so I don't have any results to report on it yet. But at a high level, we have 2 research questions. The first one is really about usability. So how do users doing EDA interact with and organize their work in Peapods? And for this, we have like an open-ended task. And then for the second, because our second research question sort of gets at one of our goals with this work is to make notebooks, which are notoriously messy and become harder and harder to use as they grow in size. We would like to make, our hope is that Peapods makes notebooks more maintainable in the long run. And so as a signal for this, our second research question is how effectively can users modify a notebook in Peapods compared to Jupyter? And this we have a between subjects task, and we have equivalent Jupyter and Peapods notebooks, which we ask people to make edits to. Yes, so that's everything I have. These are some questions if people want to ask it or answer any of them. And yeah, thank you so much.
These data scientists don't really think I want to learn.
Really great talk, thank you. What do you envision as the upgrade system? If I have a Jupyter notebook and I want it to be Peapods, is there like a path that I can take, a recommended path towards getting it into the system?
Yeah, I think that's a great question. Right now, I've really been focused on if you're starting from Peapods,
sure,
and how can you sort of gradually have people start from a messy analysis and naturally build up to a more structured piece of code. But yeah, I think that definitely adding ways of gathering your code into Peapods would be really valuable.
really cool idea. And have you thought of like reusing the pods to other pods? Like, can you use it as like a reusable encapsulated module?
Yeah, that's definitely a
So number one, can pods contain other pods? And number two, with respect to your evaluation question, it seems like you really want to evaluate a situation where like Jupyter Notebook gets really messy and people have to deal with that. So how do you set that up? And in particular, how do you make it comparable in some, or maybe it's supposed to not be comparable, but how do you do the Jupyter side of things and the Peapod side of things to kind of illustrate that difference?
Yes. Okay. First question. The answer is no. Pods can't contain other pods, though we could consider making that the case down the road. But I worry about like ultra nesting getting complicated just because of like people's mental models.
Every other module system eventually needed it.
Yeah. So I guess yes. So this is certainly something we can think about. And then for the evaluation, that's a good question. Like our current task design, we are taking like just a real world Jupyter notebook, which isn't a messy notebook. Like it's one that contains markdown headers as like sections, and we transform that into Peapods as like any markdown section becomes a pod. And so that's how we did that transformation. And so here we're not starting at like a particularly messy thing for which to modify. So that I think that it would be really cool to see a task that does start with a messy notebook. But I also didn't want to like artificially construct something that was really messy, and then like bias it towards my tool. So yeah, if you have other thoughts about how I could design that task.
I mean, you could solve that by by doing both, right? Starting from scratch or from something that's clean, and making sure you don't make things worse, and then showing that you make things better in messy situations. Has to be designed carefully, obviously.
Yeah.
It could be a way to think about it.
Yeah. Thanks.
When you described this pods thing, I almost thought of it as a sort of discipline for organizing your Jupyter notebook. So now that I know about pods, if I had to make a notebook without this concept of pods, I might try to like just hold myself to the discipline of following these input-output conventions and maybe get some of the same benefits of this stuff. So I actually don't work too much with notebooks, but I was wondering maybe you would see the same patterns of discipline or structure if you looked at the way people use large notebooks and what strategies do people use to not make them or like manage the messes. Have you looked at any examples like that?
Yeah, I mean definitely like there's sort of like knowledge shared among data scientists of how to like maintain clean, nice notebooks, and that those best practices get followed to some extent. But I think like partially this isn't just about like best practices. This is also about like limitations of the tooling itself, where like you don't have structures. There are no structures around cells that you can use. And so, yeah, I think that's kind of the difference.
Yeah, I guess there's no structures around cells, but you can have headaches. And like if I tell all my colleagues like every headache starts a new cell, metaphorically, then maybe that's a structure. But so what would you say are problems that the tool just technically can't do that this can do?
Right. I mean, there's like the local scopes and the limited like the isolated heaps that we have. So I would say that's a big difference. And then there are these enforced final orders, which that is something that we